Is the square root of 2 a rational number? Today we are going to prove that it is not using a method called proof by contradiction.
To do this, let's play a game. Let's assume the opposite is true. Let's assume the square root of 2 is rational. If it is rational, we can write it as a simple fraction, a over b.
But here is the most important rule for this proof. We assume this fraction is in its simplest form. This means a and b have no common factors. They are coprime. Remember this rule, it will destroy our assumption later. Now let's do some algebra. We want to get rid of that square root, so let's square both sides. This gives us 2 equals a squared divided by b squared. Let's rearrange this to make it linear. A squared equals 2b squared. Look closely at the right side. It is multiplied by 2. This means a squared must be an even number. And mathematically, if a square is even, the number itself, a, must also be even. Okay, since a is even, we can write it as 2k for some integer k. Let's take this and plug it back into our main equation. Substituting gives us 2k squared equals 2b squared, which becomes 4k squared equals 2b squared. Divide both sides by 2 and we get 2k squared equals b squared. Now look at b squared. Since b squared equals 2 times something, b squared must be even. Therefore, b is also even. Wait a minute. We just found that a is even and b is even. This means they both have a common factor of 2. But remember the start? We said they were coprime. This is a contradiction. Our initial assumption was false. The square root of 2 cannot be rational. It is irrational. Thank you for watching this video. You can subscribe to StickMATH for more math videos.